Hello, Ace. Hello, Eva.
Hi, Rich. Hi, everyone.
I was
Hi,
just,
Rich.
how are
Nice to
you?
meet you again. Thank you very much.
Good.
For
I,
those who don't know, like I just want to share, my husband got diagnosed during this session with cancer and he passed away recently. So I had to
Oh,
drop the work, but I admire what you're doing, guys, and I can tell you we have to do even more
yeah,
to save more people.
yeah. We're sorry to hear that. But that's the thing, it, I mean, the projects are, to do in your own time, but I understand things get in the way, and obviously you've had a hard time recently, and it's perfectly, it's fine. But I know you have been looking and keeping track of the project, and that's been good. And it's these kind of projects that develop into, can raise the opportunity for, cancer diagnosis and treatment and things like that to progress in the real world. And Omdina do quite a lot, and it's technology that, the one that we've built is probably best suited for sort of developing countries rather than large cancer hospitals now. But it's, you say, if we're saving lives basically, and that's what the point is, and to show that it can be done and how it is done, and even if it inspires a product later in years to come, it's still like we've made a contribution to that. But yeah, there's still a long way to go. But as time progresses and we develop AI, it's a lot further. I think hopefully stories like yours will be less and less. Do you know what I mean? And so yeah,
I hope so, yeah.
yeah. Well, thanks for coming to the final project anyway. It's appreciated. I know it must be difficult, but it's good seeing you. It's really good seeing you.
Thank you.
Before everyone joined, I was just saying, we've got an hour, and I want to, if anyone's prepared any sort of slides or anything, just to show what they've learned, what they found good about the project, what they struggled with, and just sort of a reflection on how you found it, and what are you going to do in the future if you're interested in computer vision, or in general, or specifically for medical diagnosis as well. Are you gonna, what's the next steps for you, kind of thing. Also, Oasis is going to demonstrate the app, and if you didn't hear, having the app, it isn't like a final, the project's over, but that doesn't mean you can't develop the app further, and and build on the work that we've already done. This is an open source project. Just because we're not going to be working as a team anymore doesn't mean that you can take this project and develop it personally, or with a few others from the group in your own time. That's perfectly acceptable. And if you do that, keep me in the loop. I'd love to know where you go with it. So yeah, that's what the sort of plan is. And there's not a hard sort of itinerary that we need to cover today. But if anyone has anything that, any slides that they'd like to share and get us started, feel free to share your screen. I'll just allow that right now.
So,
then,
Rich, how are we going to do? Always go the first, or we?
No, we'll let Always go last.
The screen, have some slides.
Yeah, we'll do all the slides first, and then Always can round it off with the demonstration of the app.
Okay. So.
Wallace, you got your hands raised?
Oh, if I can start, or Dami,
Yeah. Go ahead. You should be able to share your screen now.
Yeah, you can start. I can go after you then.
Okay.
Cool. I'll turn my camera off as well, just for the.
Let me share my screen. Let me lower my hand. So can you see my screen? And can you hear me?
Yep, you can see your screen.
So I just prepared a few slides, so some bullet points about my learning and contribution to this project. First of all, I would like to thank Rich for organizing this project. And also, I would like to thank all my colleagues for this wonderful journey up to here. In special, the very good and organized leadership from always. So at every project at Omidena, I have the chance to meet wonderful people and making friends. So this is not different here. So it was a great pleasure to me to participate in that, and I have a lot of learning regarding computer vision. It was my first big project in this front. Before that, only small tutorials and some part in a consulting job, but not with this depth as we did here. So thanks for the opportunity, right? So first point, I learned I have the introduction to the acute lymphoblastic leukemia disease. It was only basic knowledge before to me. So we have this project, we have the expert talk. So it was highly instructive to me, right? So during this project, especially in team 1, where most of the implementations were done, I have the opportunity to learn the process of transfer learning. I never did that before, so I have the time and the opportunity to understand the processing and then implement and reproduce different codes on that. Also, during the expert talk and also from different material shared in the channel, I have also the opportunity to learn some different quality metrics for classification in the health science, in the health field and medical problems, right? Also, we have the contact with image preprocessing and data set augmentation, but it was my first time in that as well. I think for myself, for me, the main challenge, technical challenge here was to deal with data leakage, data imbalance, overfitting, and distribution shift in a practical problem, in a real world problem. So it's really hard, right? So even though I think we learn a lot, and also we've tried different strategies. We had to try different approaches to deal with that. So it was quite instructive to me. So also, I had the chance to implement in Python different machine learning models for image classification. So I have this opportunity to go in deep for different machine learning models. Also, for the first time, I reproduce it and also implement hyperparameter tuning with Optuna. So Rich as well has shared to us a template, and also we had the opportunity to evolve from that. So it was good to learn that. It was really important to me in technical aspect, right? So also we've played with different feature selection methods, joining with the machine learning models, and also at the end we used also ensemble methods, stacking and vaulting. It was the first time I used that using those libs with Python, so it was good to to do that, to put that in practice. And also, I made some tests, I made some implementation in Team 2 using deep learning methods. So I have the chance to go in deep with that. And also I have the introduction to YOLO v5. So it was the first time I used that library. So it was quite good to me. So thank you very much again for the opportunity of this project. I learned a lot. In fact, I participate in different Omdena projects. So this one, it's one of the most deep for me in terms of different implementation fronts and different things to learn at one single project. So thank you very much. That's what I have to say to you. Hey, Rich, I don't know if it was like that you were thinking, but
Yep,
that's
that's exactly right. Yeah, and thank you very much for that, Wallace. That was great, and it's good to hear that you've learned a lot. The kind of, like, I've been on a couple of Omdena projects myself, and you know, machine learning, no matter what the sort of task is, computer vision or just your classical sort of classification and regression on tabular data, there's so many different ways of doing things, and each one has benefits and negatives. And I'm one of them people who learns by doing. So when I took decided to do a computer vision, I wanted people to learn as much as possible and try out as many techniques as possible. Whether they work or not is entirely irrelevant, but it's experience for the participants of how to implement various different things, how to implement stacking, how to implement voting, data augmentation, and things like that. It's all about learning, about how to implement them, because you follow your career into artificial intelligence and machine learning, you're going to have to implement these in some way or form. And by the time you get to be working in industry, you'll have an idea of what will work and what won't based on these sort of experiences. So, it was a beginner's project, but we went as deep as possible where it then wouldn't get, it'd put people off, kind of thing, where it wasn't designed for beginners. There's plenty more in computer vision that we could have done, but I think it would have been overly complicated. Computer vision's a fascinating subject, and once I've got a bit more time, of course, as you know, I've been moving house and things like that. I think having a intermediate project to follow on with the computer vision would be a good idea in a couple of months' time, because all you guys have put together, you've built a really good model using transfer learning. We've come across the sort of most popular problems, imbalanced data sets and data augmentation. Are we trying to balance the classes and things like that? So, but there's a lot more to it than that, and you briefly touched on it, Wallace, in your presentation. It's the sort of medical metrics that we need to take a look at into more depth, but also things like further from just hyper tuning your hyperparameters. There's things like conformal prediction as well, to sort of benchmark your predictions within the base rate of the disease occurrence in the wider population. So there's all these sort of further metrics that we can deep dive in another project perhaps, but I think doing it now would have defeated the object, because it's a beginner's project, and it should have served you as a good foundation into computer vision and the sort of most popular techniques and what to implement, from transfer learning to building a CNN model, or data augmentation, and all the other things I've already mentioned. So I'm just glad that, Wallace, you've learned a lot, and I think what you have learned will put you in a strong position to advance into, if computer vision is an interest of yours, to jump to the next level and to get involved into intermediate and professional sort of skill levels. and you know it's been good to hear that. Demir, would you like to take the stage?
Okay, let me try to share. Okay, let's see. Can you see the screen?
Yep.
Okay, now I'll start the slide.
That's perfect.
Okay, so we're okay now. So let's say, first of all, I was attracted to this project because 5 years ago I was diagnosed by one kind of leukemia, hairy cell leukemia, and I was always joking that if you have to choose one leukemia, this is the one that you can choose, you know, because it's not very dangerous, and chemotherapy is only 1 week for 2 hours a day. So, and now I'm 5 years okay. In a month, I have a first 1 year follow-up. Before there was always 2 months, 6 months. So that's why that was one nice thing that I wanted to learn more about this. My contribution here was mostly, I was a little bit late with start working on maybe 1 week. So I started mostly in work with the traditional machine learning classification of these features that were extracted by transfer learning. So practically I went through XGBoost and Optuna, hyperparameter tuning only. And the next that I did was a feature selection with ANOVA, XGBoost and Optuna. And the follow-up after that was a stacking classifier, where I used the XGBoost as a final estimator and these 5 estimators, classifiers as the base. And the last that I did was like a simple neural network with the Keras as an API for Keras and using PCA and Optuna. Several skills I learned here, and one most important was Optuna for hyperparameter tuning. I also learned that the very importance of parameter spaces that you define through which Optuna has to go. One example was that I had just copied from internet parameters for a random forest, and I got the 74% accuracy. Then I look and the default is giving you 84. So then I adjusted the parameter spaces, and normally after that I was getting 84, 85, even 86% accuracy. So that's very important. Also, I learned somewhere on the internet, only on one place I find how to, that is very important. You can use, if you have some fitting that is very, very slow, takes a lot of resources, then you can start with several trials in the optimized function. Then you look your results, and then you can continue. Practically, you you call again the same function, and you continue with your trials as long as you want in a small, like a batch. You don't start with 100 immediately. So that was very important for some things to do when you optimize. Feature selection using ANOVA, that was also first time for me using that. And what I did interesting here was that I used the K, that is the number of top features to select, as a hyperparameter in Optuna. With the stacking classifier, it was just a long things to work. The improvement of the model performance wasn't good enough. They are longer to train, and predictions are very slow. They are also very computationally expensive. So that wasn't. I mean, it's a good experience that you know what you can expect from it. And the last thing that I did was and learned, it was is PsyKeras. This is Scikit-learn API, ROPE for Keras. I was introduced to this last year, and this year this time I went a little bit deeper with that, and also use Keras model to optimize with Optuna. The next, so the challenges, the first obstacle that I have was with PsyKeras. We want to get the hidden layer sizes to be optimized with Optuna, but if you look here, they are practically tuples of 1, 2, or more layer sizes. So how can we do that? There were several suggestions on the internet. This is the one that I adjusted to our case. So we define number of layers as a Optuna parameter, and then we also, in a loop, we practically create a number of units, 0, practically n units 1 and units 2 parameters for Optuna. And this is at the bottom is our model hidden layer sizes parameter that we will use in a function and trial to get to optimize. This configuration here creates layers, a number of sizes of units that is always equal or smaller than previous layer. It can be changed to go to any number. So and then once when we get the results from Optuna and parameters, we have another problem because Optuna parameters don't give us this hidden layer sizes. So we have to use these 2 1 layers to adjust parameters. First layer, just remove those n layers and n units, and the second line here it just creates the new key in the dictionary, and at the bottom we have R parameters that we can use for refitting. The second challenge was that PsyKeras with the pipeline models requires separately saving Keras model and pipeline. So this is, you can see the example of our pipeline with the scalar, PCA, and the CLF. This is the Keras classifier. To solve that, there are several things on the internet. This is adjusted for our case. We need first to save in practically 3 steps. First step is save Keras model. Then you do some kind of hacking that you can save the pipeline. And after that, you just, when you need to load the model, you just load the pipeline first, and then you save the Keras model, load the Keras model. So overall experience, this was my first Omblina project, and I really didn't know what to expect. I liked a lot our teamwork. One thing that I missed was a little bit more coordination, but I was still lucky because I was, as I mentioned, a little bit 1 week, a little bit behind. So, for example, when we have an assembler working, some teammates started working with the voting classifiers. Then I said, okay, I don't want to do the same thing. I'll try with the stacking classifier. So it wasn't so bad anyway. And in the end, I really enjoyed working with everyone in the team, especially with the Rich, always, and practically everybody in the team. And I think it would be nice to, in the future, still keep in touch with many of you. Thank you.
Thank you very much. But yeah, that was fantastic. And Damir, yeah, I've also learned a lot. And what I noticed as well in your notebooks, some of the experimentation you did was fantastic. Like before stacking models and stuff, you found the optimal hyperparameters through Optuna. I thought that was a really interesting experiment, and it did okay. But as you said, stacking is computationally expensive, and it's one of them where it wouldn't, stacking, it can win Kaggle competitions, but it's I don't think, as I've said before, I don't think I've ever come across it in an industry production environment, because it is computationally expensive and it is time expensive.
And the size of the models are much,
absolutely
much, much
bigger. Yeah. So it's definitely worth knowing about. There is uses for it, but I think it more as society grows and businesses adopt AI a lot more readily, and they have a lot of resources available to them, and they improve the sort of IT architecture and whatnot, and stacking might become over time less computationally expensive. It'll probably become a lot quicker as well as the models advance. But it's at the moment it's a good skill to have, but the chances are you probably won't be implementing something like that in a real life environment. But it's still the experimentation was fantastic. So thanks very much for sharing that, Damir, and thanks very much, Wallace, as well, for sharing your experiences. Is anyone here got anything else that they'd like to share before we hand over to Owais for the app demonstration and walkthrough? Wallace, you've raised your hand.
So just one quick thing. So regarding coordination, I would like to say something. So it was difficult to me on the first project at Omidena. So I struggle in the beginning to understand the process, understand the way. So after different projects, now I understand better this way. And now I chapter lead as well. So we've got some training regarding bottom-up development approach. So Rich knows that. So Damir, what I say in this sense that one thing that I learned in the book from Abdena is the process is chaotic by design. So as leaders, we provoke this environment to make this more autonomy and self-learning and self-development. So also, this kind of process is difficult to understand and to manage, but it improves a lot of creativity. So in this sense, I think especially you, Damir, you use a lot of creativity in your code. So I congratulate you for that. So I think it's also part of the process. So Rich, you could add something as well.
Omdina projects are designed for beginners, and they're inherently chaotic because everyone is like a sponge for learning. It's and a lot of people join on the projects from the start. I mean, by the time we've come to the end here, a lot of people have dropped out and stuff, and we haven't seen them since the very beginning. But that is just the way things go. It's it's free. You're not getting paid to do it. It's entirely voluntary kind of thing, so you expect that, and it's difficult to organize that sort of thing. So in the previous in projects, I mirror your sentiments, Wallace. It can be quite chaotic, so my sort of approach in organizing it is trying to split it into smaller teams who have responsibilities that are different to other teams, so we're covering a lot of ground. And people who are a little bit more experienced than the rest can take the lead of their teams and be responsible for organizing that. I do that for two reasons, and one of them is a bit selfish. It makes my life a lot easier, and two, it gives people who are sort of a little bit more experienced that sort of project management experience as well. It allows them to take charge of a team. It allows them to take charge of work and delegate work to people who are based all around the world. And that's a very important skill to have. And, Owais has demonstrated that he is more than capable of running a small team and organizing work where everyone can stick to the plan, but be creative with how they solve the problems. And as you mentioned, Damir, he was very creative in his experimentation. Now, if we were to structure it where it was like, you have to go by these particular guidelines or these particular rules, we probably wouldn't see the creativity that we've seen, and that would have hindered the participants' learning. And so, yeah, Wallace, I think that is a really good observation. data science, machine learning, a lot of the time creativity wins, and you have to be creative. You have to solve problems by thinking outside the box. 90% of machine learning in industry is classification and regression, but then you never come across the same problem more than once. And there's a million solutions, and people are inventing new solutions of solving certain problems all the time. That's part of it, and that's why I find it so fun, is that, yes, you do need the sort of tech skills, you do need the people skills, but you also need to be curious, and you also need to be creative as well, and think outside the box and come up with revolutionary solutions to problems that your employer has. So I think the way to run a good Omdina project is try and replicate that as close as possible. Have teams who don't have any sort of creative limits. Let them go on there and let them experiment with interesting solutions they've come across during their research periods. And I think, from what we've done and what our end results has been, we've really been able to do that, and we've had a lot of great research. We've had a lot of great contributions. We've had creative solutions to the problems. We've experimented with all sorts of transfer learning models and tried stacking, voting. We've done a lot, and we've covered a lot of ground. And hopefully that has resonated with everyone, and people have been able to learn a lot from that. And of course, as I say, people who've uploaded their notebooks and whatnot, you can see the sort of the learning journey that they've been on, and it's really good to see. And the feedback that we've had, and I think we've hit the nail on the head with it. So it's good to hear. But yeah, Wallace, I can completely agree with you. We've got 6 minutes left in this call, and then we'll refresh it again. Always, do you want to make a start? Yeah, go on, Damir.
I want to say that for this, it took me some time to get used to that. So then I find, let's say, my niche in that, what I want to do and how to do, and then it was okay going to that. But it was just at the beginning was like, I didn't know what to do. I was confused.
Yeah,
especially you have a practically came with the 200 people. So, oh my gosh, who is doing what,
Yeah.
Once when that cleared a little bit, I find, okay, this is what I want to do and how that, and try to experiment there. That was much easier.
Yeah,
but the beginning was, as I said, that was my first Omdina project, so I really didn't know what to expect.
Yeah,
I was expecting maybe more like straight things. You do this, you do that, but that takes the time to adjust a little.
Yeah, it does. And even in like real life, like recently, like from my work experience, I've been put on a project that it's been running for about 3 years. And they've got an entire software package set up. There's about 100 people on the team, and I've started on this new project, and I don't know anything about the project. I don't know who's on the team or anything. So I'm like, it's like starting from scratch again. I have to, it's going to take me a month or two to get up to speed with what's going on, who does what, where I need to contribute. And that's exactly what it's like at the start of an Omdina project. You've described it perfectly, but that is what you find in real life as well. As I say, I do it every time I move a project. It's like being a beginner again, and I have to catch up with everyone else and see where my contributions will be appreciated. So, it is sort of, even though it's a bit chaotic, it is sort of prepping you for real life data science and machine learning work. So yeah, you'll probably look back on this and think, yeah, I'm glad I've done that, because I don't have that. I don't have as much imposter syndrome anymore. Nabil, you've raised your hand.
Hello, yeah, can you hear me?
Yep, we can hear you.
Yeah, sorry, I won't be able to share anything for some internet problems, so I'll just speak. So this was my first Omdina project, and it was quite interesting, especially given the problem statement and how everything was going. Even though I was not able to contribute as much as I wanted, because everything was quite new, but I learned a lot during this whole project, especially like using ensemble models and voting classifiers, especially handling the imbalanced data. So yeah, it's very interesting, and I want to thank everyone on the team, especially or the team lead OS, because he was really helpful during the whole time. So yeah, just
Well, that's great.
thank you.
That's great. It's glad to hear you had a positive experience from it. That's the thing. It's especially if you begin it is quite difficult, and you know, we try and cater towards helping out the beginners as much as possible. But it's also, you know, being a beginner, you're not really sure where you can contribute or not. But as long as you follow along, you see what people do, you look at people's code, understand the reasons people have done certain things and why they've employed certain techniques, you will learn a lot. And of course, the benefit is the GitHub will be there. And, you know, if you think, you know, if you ever are on another project and think, oh, I've seen this before and we've done something that solved this problem quite effectively, you can go back and still learn from our GitHub and download the notebooks and try and put it into your own personal projects as well. So you've got like a wealth of knowledge there that is freely accessible, and you know that it's being implemented in real life and you know how it works and things like that. So it's not just, you know, even if you follow along and don't contribute that much, it's still a beneficial experience. And you know, I'm glad you did have that positive experience and you have learned a lot. And again, I say, you know, it's entirely voluntary, the MDina projects, and you know, no one's getting paid, and you know, people's lives are busy, people have full-time jobs, people have got kids, people have, you know, we've got all sorts on, so no one is expected to be 100% there all the time, kind of thing. All we ask for is that you try your best, you turn up as much as you can, and you learn as much as possible, because that's the most important thing, is how much you learn. What I'll do, we've got a minute left, so I'll restart this call and then we'll go straight to Oais to demonstrate the app and walk us through that. So if you just refresh your meeting, we'll be back in a couple of minutes. Just give Oais a second to join back on. So yeah, we've got about 20 minutes left to call it an hour. So what we'll do, we will let Oais demonstrate the app, and then once he's done, I'll give you you know, a few final thoughts, and we'll take it from there. And I think we can, you know, we can end on a positive. We've had a fantastic time so far, and you know, we've put together a really good project, and I'm glad to hear that everyone has learned a lot and see it as a positive experience. Oais, do you want to share your screen and demonstrate and give us a walkthrough on the app?
Yeah. You guys can see my screen, right?
Yep.
Yeah, so first of all, thank you, Rich, and everyone, for your kind words. It was really delightful to hear that, and it was really encouraging. So thank you, and I'm happy that I was able to lead you guys in a way that you guys have learned as much that you have, like you guys. It's just really good to know that the project was a good learning experience for everyone. Yeah, and personally, I've also, there was a lot of things in the project that were new to me as well, and there were times in the project when I felt like this would be too complex for me to like try out or like that. But I'm glad that we tried it out because we were able to do it successfully. And yeah, so I learned a lot of stuff along the way as well. So about the dashboard, so this is the main homepage of the dashboard. And what we are going to do is that we will upload an image here, and then so this dashboard is running our trend model in the background. So it will predict it will pass in that image to the model, and it will tell us whether that image is an all image or it's an him image. But before doing that, I want to go to the details page and just quickly go over the whole project, like what we did and from the beginning to the end, and the challenges that we faced and stuff. So this is the flow chart, or you can say it's the flow chart of the training pipeline. So what we did was that we had our data set. So we noticed that our data set was imbalanced. So the number of him images were way more less than the number of all images. So what we did first is that we augmented our images to deal with the data imbalance problem. And then we cropped our images just to remove the irrelevant pixels from the image. And then we passed that pre-processed image to a pre-trained VGG16, and Neville also used a pre-trained ResNet. And so we passed the pre-processed images to both ResNet and VGG16, and we got extracted features from these two models for each image, and then we passed those extracted features to our classifiers, and then our classifiers, based on the features, our classifiers were able to tell whether the image belong to the all class or him class. So yeah, this is the overall flow of the project. And then this is, like I've already discussed, it's the data imbalance issue. And the reason that I have included it here in the dashboard is because data imbalance is a very serious problem for a data learning for a deep learning project or any machine learning project. During our last project that I was working with Rich, so the data set that we had on that in that project was also an imbalanced data set. And it's really hard to like deal with imbalanced data. And from my personal experience from the previous project and this project, working with imbalanced data, if I ever come across an imbalanced data set in a real world, like in a real world scenario, the first thing that I would try to do is to just get more data for the minority class before like trying any augmentation or any other technical method to deal with imbalanced data. Because it's really even if you generate augmented images or you deal with the imbalanced data in any other technical way, it's really hard to generate the exact same instances of the minority class. So in real world scenario, my first choice would be to like tell the client to get me more samples of the minority class. So yeah, so that's why I included it in the dashboard, because it's very critical to the performance of the pipeline. And this right here is a quick summary of all the of some of the experiments that we have been running throughout the project. The images are blurred. Sorry, I should have taken care of it, but yeah, so the first confusion matrix that you see here is a confusion matrix that of a model that we trained on the data before performing any image augmentation or any pre-processing steps on the data. So this is a confusion matrix that we obtained from for the raw data set that we had. And you can see here that the model is having trouble classifying the images of him class, and that's because of the data imbalance. And this is a good description of this confusion matrix. So the him class was misclassified 38% of the times. And then what we did was that we performed image augmentation and trained a model on it. So it did improve the performance a little bit. I am not sure if you guys can see this digit clearly here. So it's 98 here, and the one line summary is that in this case the him class was misclassified 29% of the time. So it's just it just goes to show that image augmentation did improve performance of the model a little bit, and not a little bit. I would say if it was a real world scenario, then this 9% improvement is very significant. Yeah, and then what we did was that we were trying to improve the performance even more. So we moved on to ensemble learning techniques, and we tried voting classifiers and stacking, and this is the best model that we had from those experimentations. So here the him class was misclassified only 82 times. So out of I think 460 times. So the performance was improved slightly more. And then this is what this is the confusion matrix that we got from training a very simple neural network. This is the neural network that Damir trained on the data. So it boosted the performance even more. So yeah, so these confusion matrices, this just shows the overall flow of the project, what we had at the beginning and what we had after augmentation, and then what we had after voting classification, and what we had at the end of the project. And yeah, so there were a lot of experimentations that have been done on the data, and this is just a table that I was preparing throughout the project to keep track of all the experiments. So I will mention that these are 13 experiments, but the actual number of experiments were way higher than this. So at least there were like 21, 22 experiments, but I only chose the one that I thought would be good to keep in the table. So there are a lot of numbers here. I will not go over each and every one of them, but I will just quickly tell you the critical parts of this table. So this highlighted green experiment that you see here is the best experiment. It's the one that I just showed you, the confusion matrix, the final confusion matrix. So this is the best trained model. It's a simple neural network, and the red ones that you see here is the numbers may seem like very good and convincing, but these are not trustable results, because in these experiments we accidentally encountered data leakage. So these red highlighted experiments, the results from these experiments are not trustable, and the rest of these experiments are just all the experiments that we have been doing throughout the project. So there is one main thing to notice here, and that is that if you can see, all of the experiments that we have conducted are not all of them, but 99% of them are done with traditional machine learning models. And we tried to like do all kinds of feature pre-processing, like feature selection, ensemble learning, and hyperparameter optimization with the simple machine learning models. But the best result, but still the best result that we got were from a neural was from a simple neural network. So this just goes to show that neural networks just do a better job on this type of data. And yeah, that's all from the table. And the challenges that we faced during the projects for the first one is imbalanced data set. I've already talked about it. The second one was, for me personally, and I'm pretty sure for many of you as well, it was computing resources. So that we were dealing with an image data set, and images that take a lot of memory for computing. So I personally, and I am Neville and others from us, a few others from the team ran into this computing resources issue. Even though Kaggle and Colab offers some free resources, but I think Kaggle offers 12 GB free RAM, and 12 GB was also not enough for the amount of experiments that I personally was running on the data. Another challenge was that there were too many possible ways of approaching the solution, and which required a lot of experiments. So we have done a lot of experiments already, but there are still a lot of stuff that we could have done to improve the result. So yeah, and the next was that, as I already mentioned, we 99% of the time we use the traditional machine learning algorithms instead of neural networks. And neural networks perform significantly better on image data. But yeah, but the main objective of my team was to try traditional machine learning algorithms on the data. So this is just to show that if someone wants to further improve the results, that they can just move on to use neural networks on the data. And Rich has already trained a neural network on our data, and he has obtained pretty significant results. So this is the results that Rich has obtained while after training a neural network on this data. So here you can see that the misclassification rate of the HIM class is significantly decreased. So yeah, so it's just to show that neural networks can significantly improve the performance on this data. And the future work would be the first thing that someone could try to improve on the performance is to fine tune the pre-trained network. So fine tuning is a technique that is usually used. So we use the VGG16 and ResNet pre-trained VGG16 and ResNet, but we use them just as they were, like in their original shape. And there is a way that we can alter the original sequence of layers and everything of a pre-trained model. It is called fine tuning. So one thing that someone would like to try on the data to improve the performance is to try fine tuning the pre-trained models. And the other is that we only had enough time to use VGG16 and ResNet for feature extraction. And there are a lot of other neural network architectures that could be used to extract features from the data. So someone could use mobile net or efficient net, or there are all types of different types of networks. So yeah, this was all about the background of the project, and now we will talk about the prediction pipeline. So what's going to happen is that we will take a raw image and we will upload it, and then some pre-processing will be done in the background on the image, and then we will then that pre-processed image will be passed to a pre-trained VG16, and then the VG16 will extract features for that image, and then those features will be passed to a classifier, and then that classifier will tell us whether the image belongs to an all class or him class. And yeah, so let's now just move on to and see what happens. So what I will share. Let me just share the link to this. So this is the link to the app. I shared it in channel. It is deployed, so when you guys click on it, you should be able to like open it in your PC. So what you can do is that let's say if you don't have an image to try out, you can just click on this example image. It will take you to this GitHub repo, and then you can just click on this download raw file, and it will download an example image that you can just try to upload here. In my case, I already have images, so I will just go ahead and pick one image from my directory. Click on it, and let's just wait for it to finish uploading. So once the image is uploaded, it will pre-process the image like we talked about. It will do some pre-processing on it. So in this case, the pre-processing is that the extra black pixels from the sides of the image will be cropped. So in the pre-processed image, you see that all the extra black pixels are cropped, and the shape of the image will be converted to what the model expects it to be. So yeah, there's the pre-processing step. Then, like we said, we will have to pass this to a pre-trained VG16 to extract features. So when you click on the extract features, this image is then passed to a VG16, and we will get the extracted features for this image. And after that, these extracted features will be passed to a classifier. So when I click on the classify image, it will pass these extracted features to our trained model, and it will tell us whether the model whether the image belongs to a him class or an all class. So and this is this is just the teams page. So here I have added some member of the team and some details about it. I haven't added everyone. So if there is someone that is not here, I am sure there are all of you are not here. So just send me your LinkedIn profile link, and I will add your info and everything here in the dashboard. Yeah, so that is all about the dashboard. One thing I would like to mention is that if you try this model right now, you will notice that the model is biased toward all class. So it is having trouble classifying the him class images. And that's okay, because we had the data imbalance issue, and we tried to do image augmentation, but image augmentation, in my personal experience, what I think is that image augmentation doesn't always works in favor of the model. So you will you will sense bias towards the all class, but that's just part of the project. We shouldn't be worried about it. We have created a good benchmark web app, and the model that we trained, the model that this dashboard is running in the background, we can change it. We can always change it. So in future, if someone was able to train a better model, we can just change it, and then the predictions will be much more accurate. Yeah, so that's all from my side. If anyone has any questions, regarding the dashboard or anything. So please go ahead.
Yeah, that was great, always, and it's a really well put together web app, and it demonstrates, you know, all the hard work that we've done for the past couple of weeks really well. It's 3:30 where I am now, so we've had an hour and we've run through some presentations about what people have learned. We've had a fantastic review of the web app that Oasis developed, and it's, you know, a reflection of all the hard work that we've done. So to close out, there's a couple of things. One, of course, I'd like to thank everyone who's been on the project. Everyone has put in, you know, a real good effort, and hopefully everyone has learned a lot as well. And I hope you've seen the benefits of doing Omdina projects. You know, it's just, because it's just, you know, it's free, and you know, you work with like-minded individuals across the world. It's a really good learning opportunity, and it's good to see that everyone has had a positive experience. I'd also like to say as well that your Oasis put a lot of profiles on the web app, and that is one way to help boost your network. So what I would suggest that everyone add each other on LinkedIn and leave each other reviews about how you've, you know, about your experience working with this particular person, and that'll help strengthen your LinkedIn. It'll help you, you know, if you've got a lot of positive reviews from people who you've worked with a team with around data science or machine learning, it's going to make your life a lot easier to get jobs in industry. So that is something I think is quite key. But I'd like to especially thank Oasis as well, because he was the team lead for team number 1, and his organizational skill has been fantastic. His development's been fantastic. His tracking of experiments has been really good, and of course he was the designer of the web app, which is very impressive. And the fact that we can, you know, all you guys can use this as a project in your portfolio, and you've got such a fantastic app to show people where you've contributed and how your contribution has materialized into a real life, you know, diagnostic tool. So yeah, thanks very much for that, Oasis. It's been great, and of course it's been a pleasure with working with everyone. Everyone's really put the best foot forward, and I've been impressed with all the work that you've done, and I'm sure you guys are going to go forward and achieve some great things in data science and machine learning. If you put as much effort as you've done in the rest of your career, you'll have no problem whatsoever. It's really been good to get to know you guys and see you develop from day one all the way until now. So thanks very much. I'll be running more Omdina projects in the future. I'll probably be taking a couple of months break at the moment. I've got things on in work and in my personal life as well that I wouldn't be able to properly put forward a project. So yeah, I think we'll end on that. Thanks very much, everyone. It's been really good, and we'll stay in touch. And of course, let's all connect on LinkedIn and keep these relationships going. Have a good day, have a good weekend, and thank you for being a part of the journey.
Thank you, Rich, for hosting this project for us. I would like to just mention one thing. We talk about these projects being free. This was my 4th project, Omdina project, and it's free in terms of money, but I never see this project as free, because I've always learned a lot of stuff while working on this project. So I see it as something that I get back from for putting my time to a project. So yeah, so it's free, but it's not free in that sense. So I think the main goal for us beginners should be to learn as much as we can.
Absolutely. Time isn't free, of course, but yeah, the more you put in, the more you get out. And Oasis has done a couple of projects in his time, and it shows. He's done really well. But yeah, if that's it, then we will catch up soon, hopefully. Stay connected on LinkedIn. I'll keep the Slack open so you can share your experience and anything else that you do in the future. That'll all be there, and all the resources will be there as well. But yeah, I'll give you back some of your weekend. Thanks again. I'll see you all soon.
Thanks, everyone.
Thanks.
Bye.
Bye.
Thank you.